Hello, I'm Dr. Papiya Bhattacharjee. In this problem, we will have to complete a table to determine the balance A. So A is right here on the table. When you're investing $3,000 at the rate 3% for 10 years, and the money is compounded n times per year. So here we have all the n values. So for each n, we have to figure out what is the balance when you invest $3,000. So let us first write down what we have, and then we have to use a formula to calculate the balance A. So what do we have? See, we have this $3,000, and that's the principal amount. So P is given to be 3,000, and then this 3%, that's the rate, so call it R, that is 3%, which is same as 0.03. What else given? 10 years, so that's the time, so T is 10 years. And we have to figure out A. Okay? So when you are compounding n times per year, so compounding n times per year, in that case, the balance is determined by P times 1 plus R over n to the power nt, where we know what P, R, n, and t they are. But we also look at the table, the last thing we have to figure out is the continuous compounding. So the formula for continuous compounding is A is equal to P times e to the power RT. All right. So let's see. For the first part of the table, we have to plug in the various n values and figure out the balance. So let us write down here what we already have, because we have to determine A, so we have to plug in all the different values that we know. So we know P is 3,000, so this will be 3,000 times 1 plus, we know R is right here, 0.03, and then n, we have to figure out various n's, so we'll do that along the way. And in the exponent, we have n times t, well t is 10, so we'll have 10n. Now, let us plug in various n values and figure out what our balance will be. In order to do that, let's pick a calculator and let us plug in this entire formula with starting with n equals 1. So for n equals 1, we have 3,000 times 1 plus 0.03 over 1 to the power 10 times 1, so it's just 10. And we get 4031.75. And these are all in dollars. The A values are. Okay, so let's continue. So now n is 2. Let's use the same formula, except now instead of 1, you plug in n equals 2. So let's do that. And you have 4040.57. Same way, plug in n equals 4 next in the same formula. So 3,000 times 1 plus 0.03 over 4 to the power 40. You get 4045.05. Let's continue. Next, n is 12. Use the same formula, except instead of n equals 4, you write n equals 12. And you have 4048.06. last value using this formula is when n is 365. So let's write n equals 365 and your value becomes 4049.53. All right. Now for the last A value, we want continuous compounding. So we have to come back to our next formula here. And in this case, you plug in P equals 3000. And it will be e to the power r times t. R is 0.03 times 10. So this is 3000 e to the power 0.3. So let's plug that in our calculator, and you get for continuous compounding, the balance will be 4049.58. So now that we finished our table, let me point out what this really means. Notice that we are figuring out what is the balance when you invest $3,000 for various n's. Now what these n's really mean? Look, n equals 1 means that you're compounding that amount annually. So when you do that, your balance is right here. For n equals 2 means you're compounding it semi-annually, and you get your balance, and so on. So n equals 4 means you're compounding quarterly, 12 means monthly, and 365 means you're compounding it daily. So for various n's, you get various balances. And see, the balance is increasing for when n is increasing. And finally, we're continuously compounding. And then you have your balance right here. So that's what this table represents. Thank you.